This is our Rube Goldberg project for Mr. Week's class. I'm in first period on B days.
I'm in fourth period on A days.
So we're going to go and explain Newton's 3 laws, and then we'll show you our machine.
Yep. And thanks for watching.
We have this little marble. And since it has a small mass, it'll have a bigger acceleration as it goes down this ramp here, which will cause enough force to make the mousetrap down here go into motion. And that's Newton's second law, and then Newton's first law.
We actually ended up trading the marble for a toy baseball. The baseball is hollow plastic, so it has about the same mass as the marble, but more surface area. We switched because the baseball hit the mousetrap with more ease and with the same amount of force.
Our second system, we have the mousetrap, which, as Hannah demonstrated, the marble will knock over, and once the mousetrap gets knocked over, it will pull on this string, which will then cause the plastic cups to move to the side. This goes with Newton's second law because the cups will accelerate in the motion of the force, the direction of the force, and so once it gets hit and the string gets moved, the cups will move to the side, thus releasing Boo and her cart to gain acceleration downward because of gravity. This also goes with Newton's first law because Boo was in rest, but then once the gravity was acted on it, she was to be able to move into motion.
We also, unfortunately, had to switch Boo out of our machine. We replaced her with an empty pill bottle for the same reason as the baseball. It had the same mass as Boo in her rolling cart, but more surface area, so it would actually hit the broom. We love Boo, but she wasn't cooperating, so the pill bottle replaced her.
So as Kaela was explaining, when Boo is released via the cups, she's going to roll down this ramp because of gravity, and she's going to hit this broom. Now, since the broom has a force acting on it, as Newton's first law says, it's going to change its state of motion and it's going to fall. And its acceleration will in turn cause a force to knock over this book, which will knock over this book, which will knock over this book, and it will in turn fall here onto this leverage mechanism. And this is all because of Newton's first law. And from there, this leverage system will move up and the ball will start to go. This is based on Newton's third law, which states that for every action there is an equal and opposite reaction. Since this action is happening, this moves down, it's a downward action, and there's an upward action here, which in turn moves the ball to go down its path.
As Hannah explained, the ball will be released and it will travel down this path, and once it falls, it will hopefully land here, thus knocking over the dominoes. They will then knock over until it gets to the books, until they knock over. Newton's laws are very involved with this because, especially with Newton's first law, whereas each object in motion will stay in motion until another force is acting on it, and the same thing with rest, because with the dominoes, they were at rest, but then a force was acted on them, and so they kept moving. Also, once it hits the books, there will be more of a mass to contend with, so their acceleration will slow down, and there will also be more force needed to move them. This goes with Newton's second law, and that will then lead to our next system.
So the dominoes are going to end up leading up to the knocking over of this giant book over here. This is because as the mass slowly increases, the force increases due to Newton's second law, so that the small mass of the dominoes leads up to bigger and bigger masses of blocks and of wood, until the bigger block of wood can knock over this big book. The big book, as you can see, is attached to this twine, which is in turn attached all the way up here to this pitcher of water. And with luck, the book will pull the string enough that the pitcher will fall over and pour into this cup. And that is our Rube Goldberg machine. Kaela!
What?
I need some water!
Fine. couldn't you just pour it yourself? What?
So the thing is, the ball, when it hits the bucket, it goes. Well, maybe do you want to try?